A very good morning, good afternoon and good evening to all my friends, participants and students for this course, the title of which under NPTEL MOOC series is Application of Forecasting, Regression and Time Series Models. And as you know, the three main broad topics are forecasting concepts, second is regression concepts and third is time series. And we are still in the first topic, which is averaging techniques and forecasting. This is lecture number 24 for the 5th week, which is with the 25th lecture, we should be able to wrap up forecasting as I had promised. So, as you can see, the overall topic which we are going to consider in this 24th lecture is about Holt Winter multiplicative concept in seasonality. Now, in this slide, this is exactly the same slide which you have seen in the last class, but there is slight addition in coloring concept which I have done. If you see here the part which I am not going to mark anymore, this part related to level, you are dividing yt divided by s with the corresponding suffix. The part in the additive one, it was just a subtraction. So, that has already been highlighted in the slide. So, when you get the slides, you can easily make out where the differences between the additive and the multiplicative parts are. The second trend remains same. Third, seasonal concept, again you see it is highlighted yt by lt, there it is minus. And the fourth part is forecasting. So, in that case you will see there are three terms which are being added up. Here you see the concept of LT plus BT into M is being multiplied by ST minus 1 plus M. So, that is why I wanted to highlight it. I should have done it when we are considering the additive one, but I thought as I was proceeding in the class, I thought that rather than mentioning time and again, maybe if I could have done it much earlier, things they are not unclear to you all, I am sure all of you, because I have been going very slow going into the depth of the problem. But when you refer to the slides, so things would be much clear to you and where the difference between the additive model and the multiplicative model is, or where the differences are. So, with repetition you have y, I am not reading the suffix y, f, l as actual forecast level, then small b as the trend, capital as the seasonal concept, small as the length of seasonality, m as time period ahead you are trying to forecast, alpha, beta, gamma are the corresponding level, trend and seasonality weightages. Again you choose the metric which gives you the minimum error. Error can definitely have different connotation. So, this is the data set, 24 data points for 6 years, each year having 4 quarters, which each quarter being a season, and you have, I have assumed values of, say, which you will change and find it out, alpha, beta, gamma accordingly, such that we are able to minimize the error. And here m is considered as 1 because you are proceeding one step at a time, small s is 4 because in each the total number of seasons is basically considered. Now, these are the concepts which you have considered for L, B and S I's, and having said that, we will come back to the Excel sheet which we are doing. So, this calculations are, again I am highlighting, you are taking the red part is basically L4, then is B4 and S1 to S4 are there, the concepts have been copied accordingly, the arrow marks shows it here. So, this is basically 380, 9.75 and S1 to S4 are given as 0.95, 1.01, 1.14 and 0.90. And I utilize this concept of the multiplicative model which I have explained and I just copy it. Only remember, m is fixed as 1, beta is given as 0, gamma is given as 0, beta is 0.4 and alpha is 0.95 and s is 4. So, when I have that errors. So, these are the errors which are calculated. So, let me check how the errors look like, just a random check of the, so this is the error how it looks like. I won't be retaining this graph, but I just wanted to show. Now, if I keep changing the values of alpha and beta, let me check. So, if I have as alpha, say for example 0.25, so the error happens to be this. If with 0.95 beta is changed to 0.9, this is not marginal change. So, basically the error depends on alpha. So, with 0.9 if I change it to say 0.1 of alpha, so the error changes. If the error the alpha goes to 0.9, there are this. If beta is 0.1, again very small change. So, this gives me the concept of the error. Now, I need to find out. So, I am removing this graph because this was just for illustration how the error looks like. Now, with values of alpha, beta, gamma, so let me take alpha as 0.9 for the first case, beta as 0.1 and gamma as, so let us take the second case as alpha as 0.9, beta as 0.8 and gamma as 0. Next case I will take alpha as 0.5 and beta as 0.1. I'll change the values and get the values, and gamma is 0. So, I am just assuming these are the values, then I will change it. Consider alpha as 0.5, beta as 0.8 and gamma as 0. So, first is this column which I will fill up with values. So, what are the values? They are the errors. So, I will get the errors, let me mark that that is what we are getting. So, when you refer to that, there should not be any confusion. So, these are being copied here. So, these are the errors. I will move it one step down. Perfect. So, these errors so it should be line which is black and of length 1.5. So, this is the graph which we will work with. Now, for 0.9. So, 0.9 and alpha is 0.1, gamma is 0, these are the errors. So, let me copy it. They will be value copied only because they will keep changing depending on the answer. Now, I go to the values of, so technically there are how many values? There are 20 counts. Here also there are 20 counts. So, the last cell can be ignored. Just 1 minute. Done. So, it is absolutely perfect. Now, so next value is beta alpha 0.9, beta 0.8. So, beta 0.8, I get the errors. I copy it in this cell. Next is alpha is 0.5, 0.1 for beta. Gamma remains as 0.5 and this is 0.1. So, these are the errors. I copy it. Last one is 0.5 and beta as 0.8, gamma as 0. So, now I have these. So, I need to plot them. So, if I need to plot them, just to show. So, these are the values of the errors which you see. So, here the blue line, I will make it red. No, this is blue, should come out here. Perfect. So, I will make it red, is for alpha 0.9, beta 0.1. Then the orange one I will mark. Yes, so I will mark it as violet, is basically for beta 0.9, alpha 0.9, beta 0.8. Then I come to the gray line. Oh, no, it is not taken yet. Let me check, because they are almost superimposed, it becomes very difficult. So, hopefully, this time I am able to take. Yes. So, I will mark it as, say for example, green, and finally, the yellow one, it should be fine. So, here are the graphs. I will not save it, but just I am showing you, because the basic calculation, everything is in the Excel sheet. So, the red, violet, the green, dark green and the yellow are the corresponding error fluctuation for 20 time periods, because you are omitting 4, if you remember. Why 20, not 24, 20, because 4 time periods are already in the are considered to find out the seasonality concept. So, here you see the graph. So, now let us check the average values. So, mean value I write down, I will just increase the zoom here. So, the mean value, and I will also find out the standard deviation of these errors. So, I will mark them, the one here as orange, mean, and this one as standard deviation. I will mark it as, say for example, green. So, the mean is average for these values. For alpha 0.9, beta 0.1. So, 0.28. Next value is minus 0.37, average of. Next value is 1.84. Next value is minus 2.15. Now, I find out the standard deviation STD. So, there in Excel sheet there is STD v.p.s. Basically, it means for the population and sample and so on and so forth. So, let us not go into too much detail of statistics. I will use the first formula, which is for the population, considering that is the whole set of data which you have. EV.p, and I have the standard deviation here is 84.45, and the other values are 83.31, 85.20, 84.21. The standard deviation value as such does not change much, but the mean value is definitely an interesting aspect to see, because in the first one it is 0.28, next one is minus 0.37, then is plus 0.184, minus 2.8515 and goes on. Now, if I want to find out the mean absolute error, so mark it as light blue and then this. So, this is done. Now, mean absolute error would be the mean value of 2020. So, I find out it is all the sum, absolute sums. So, ABS of first value. So, first value is 2R279 plus ABS. This is 279 R279, because I will copy it and make it. So, it is R279 to 298. So, basically, so it is ABS R279 280 done. Next value is 281, 282, 283, 284, 285, 286, 287, 288, 289, 290. So, what was the last value? Was 298, 291, 292, 293, 294, 295, 296, 297, and the last value is 298. So, I have all the values, they would be divided by 20. So, this is the formula for the mean absolute error. So, if I go here, I copy. So, let me check whether I have taken all the values. Yes, I have taken all starting from 279 to 98. Perfect. So, all taken together. So, the value comes out to be 70.52. If I copy it for the next cell, the average value mean absolute errors comes out to be 69.62, 70.20, 70.14. So, next cell means in the sense that I am trying to find out the mean value, standard deviation, mean absolute values for these combinations, 4 combinations of alpha and beta. Again I will repeat, the first case being alpha, beta, gamma being 0.9, 0.1, 0 respectively. Second combination being for alpha, beta, gamma being 0.9, 0.8, 0 respectively. Third combination being 0.5, 0.1, 0, which is for alpha, beta, gamma respectively, and the last combination for alpha, beta, gamma being 0.5, 0.8, 0 respectively. So, you can have different combinations and try to find out what is the best such thing to consider. So, having said that, I will again return to the slide. So, here is one snapshot which we have already done in the Excel sheet. So, if you see, the time periods is given in the first column, which is the year here, the next being the quarter, third being period, and fourth, fifth, sixth, seventh, eighth, ninth are corresponding to YT. I will put mark here YT, then is LT, then is BT, then is ST, then is FT and the error, and all the calculations which you have done, they were shown accordingly in the Excel sheet. So, for some combinations I have given you some list. Here is basically the values which I take corresponding to error, the sum of the errors are given. So, the corresponding alpha, beta, gamma are, as you can see in the 4 columns, are the first case is 0.882 for alpha, 0.055 for beta, gamma is 0. Second column or the second combination for alpha, beta, gamma is 0.7, 0.07 and 0. Third column is corresponding to the combinations of alpha, beta, gamma is 0.2, 0.03 and 0. And the last column is basically corresponding to the combinations of alpha, beta, gamma is given as 0.95, 0.4 and 0. So, these error plots which you are seeing are for the one which you just discussed, and if you remember, when I had gone through the Excel sheet, I plotted the errors for all the combinations, different combinations. And with this, I will try to end the 24th lecture, and I will start off in the sense 24th lecture in the sense that the overall coverage has been done, but I will now not go into any more PPT slides. I will only concentrate on the Excel sheet. So, I will basically close it. So, this PPT slides will be shared with you all. Now, coming back to the Excel sheet. So, here, okay, I did mention something about the Excel sheet. So, this first sheet in the Excel file, sorry, is basically about all the distributions. I am not going to go into that, people can check. They have all the distributions drawn very simply using the Excel file. Simple things like normal, exponential, Poisson, anything you have. Now, come to the forecasting, all the calculations for different things are shown and they have been marked accordingly. Now, come back to the case here. These are some of the data set. I am scrolling up, but do not worry, when you get the Excel sheet, you will understand. So, if you remember in the first class when we had done the Indian monthly average rainfall, this is given here, which starts in cell Q2 and goes on. So, that was the one. Now, if I and all the data points were for year 1901 till 2011 for January till December. No, I think maybe no. I had done, if I remember, the temperature for New York and the corresponding concepts we will come later on. So, this is the Indian military expenditure and this is the Suez Canal data. There is a GRE TOEFL scores, there is an Australian monthly electricity bill and all these things. So, let me basically plot the Indian military expenditure year wise. So, this is given in the cell starting AF4, A for Allahabad, F for Faridabad, AF4, and the data is given in US dollars 10 to the power 6, and if I plot it, I am only using the, so this is the plot. I will not save it, I am just showing you. So, this is the plot where you can utilize the concept of ideas of forecasting. So, this is one. If I take the Suez Canal data, which gives you the vehicles total and the net tonnage along with the daily average. So, if I basically plot the total from 1975 to 2019. So, this is the vehicle numbers which are there. So, if I go to say for example, the data set, I go to the average values. Wait, let me check. So, if I go to the daily average only, this is how the daily average changes. So, this is year wise. So, you see there is a pattern in both of them obviously. So, if I consider the total tonnage, so this is the total tonnage which I have. So, if I take the total number of vehicles, the first one, then daily average, which is the second graph. So, I will make the coloring difference different. So, there is marker, let me use the marker as red and width size of the markers as say for example 5. So, this is for the first one. Second one, if I make marker, if I make it violet and with a point size 5, so this is for the second one. Now if I make it for the numbers, the marker, and I use the green color, again width of the markers is 5, this is the one. So the first graph is basically related to the vehicles, the red one. The second one is violet one is for the daily average. The third one, which is green, is basically for the total. And if I basically find out for the average here, I plot it. Let me check. I'll use a different color for the markers. Let me use the orange one and increase the marker size. So here which you see, and I'll basically take it in sheet 3 for better visibility. So chart, this is just to show you, because we have discussed many problems. This is total, this is for daily average based on total. So let me write based on total next one is tonnage total, which is the green one. So the first one was basically total. I'll try to total vehicles or vessels, not vehicles, sorry, vessels. And this is tonnage for vessels. Vessel tonnage, total vessels, this total amount in tons. So basically I make it 25, bold, I have this. And finally this is the average daily based on total vehicles tonnage. I go to here, make it 25 and bold, done. So I have 4 graphs and copy it in the third sheet if possible to make it much better for us to see. So I'll copy just the figures, so we can have a look. So this is for the picture I am copying. Total vehicles, vessels from 1975 to about 2020. This is for the daily average based on total. Copy the picture, go to sheet 3. So you see total vessels and daily average based on total. Now if I come to third graph, which is for total vessels tonnage, and the last one is daily average based on total vessels tonnage. Now you see the pattern for total vessels by daily average, obviously it will mimic but the tonnages are increasing, which means that on an average the amount of goods being carried by each vessel is increasing. So, hence there is an upward trend. Another thing which is important to note, and this is just for information, if you note down here, which is in the year about 2006 2010, there has been a dip. So, that you have to basically find out considering political, economic, all these reasons, which is not under the ambit of the course, but I just wanted to point it out. So, I would not save these. You, when you are checking the video, you will have this, you can plot it, no problem. I will delete this from sheet 3, and similarly the data data is already there. So, you need not worry, you can utilize the data which is here, which I said Suez Canal data, and the link is given, the URL is given, you can basically have that. So, with this I will end this 24th lecture. I do not think so there would be much of extra coverage. So, I had promised that I will start the 25th one, continue with the forecasting, but it seems that we have given enough coverage, enough time of forecasting, and when you see this Excel sheet along with the PPT slides, I think it would be give a huge amount of understanding, huge amount of data set based on which you can apply your methodologies for forecasting. The concept of forecasting which you have covered, if you remember, moving average, different types, exponential moving average with fixed parameter, one parameter, fixed multi-parameter, which is non-adaptive parameter concept, then adaptive one parameter, adaptive multi-parameter, then we went into Holt linear method, then we went into Holt Winter method. In Holt linear method, we considered the concepts of level, trend. In Holt Winter method, we consider level, trend, seasonality being additive, multiplicative, and I have already highlighted all the nuances in details. So, I will end this forecasting part, and from 25th lecture we will start with the regression model. Thank you very much for your attention, and have a nice day.